In this video, I'm going to answer question 7 and 8 from Mathematics Choice Sheet 4, which is on trigonometry. Please make sure that you subscribe to my YouTube channel and hit the notification button so that you won't miss any video that I'll post in the future. Your support, guys, always motivates me. I always appreciate it. So, in this video, I'm just going to focus on 2 questions, and then I'm going to make another video where I'm going to solve the rest of the questions that will remain. So make sure that you hit the notification button so that every time I post a video, you get notified. So I'm going to start with question 7. Question 7, it is on identities, and then question 8, it is on trigonometric equations. So for you to solve this kind of questions or these questions, you need to have some basic knowledge or some knowledge on identities and also the unit circle. They are very important. You need to know that. So let us see question 7. Let us solve question 7. So question 7, we've been told to prove that cos x over sec x plus tan x is equal to 1 minus sin x. So this is the identity that we've been given. So for you to solve this kind of an identity, you need to have some knowledge on the inverse trigonometric identities, and also even other identities which are very important, because we are going to find some questions where we are not going to use the same inverse trigonometric identities. So you need to have knowledge on half and double angle identities, and also Pythagoras identities, even inverse trigonometric identities, sum and difference identities, and other. So they are very important. So here what we want to show is that what we have on the left hand side is equal to what we have on the right hand side. So we need to show that cos x over secant x plus tangent x is equal to 1 minus sin x. That's what we want to show. So always remember that you should start with the most complicated part, and then you derive the less complicated part. So we're going to start with cos x over sec x plus tan x, and then you are going to derive from that 1 minus sin x. So let us rewrite cos x over secant x plus tan x. So cos x is going to remain the same. Then secant x, so we are going to use the inverse trigonometric identities. So we know that secant x is equal to 1 over cos x. So sec x is the inverse of cosine, or cosine is the inverse of secant. So what is sec x? We're going to replace with cos x, with 1 over cos x, sorry. So 1 over cos x, then plus tangent x. So tan x is equal to sin x over cos x. So you need to be familiar with these identities. As you can see, they are very useful. So this is an identity, and also this one on top. So another identity. Where there is tan x, we're going to replace with sin x over cos x. So sin x over cos x. And then we are going to add the denominator. So we're going to add the denominator, okay, because of space. Okay. So we've got cos x over 1 over cos x plus sin x over cos x, okay? So we know that cos x on top, or the numerator, will remain unaltered. Then cos x is the denominator, right? For these two fractions here. So for these two fractions, cos x is a denominator. So the denominator is cos x denominator. So cos x into that cos x, it is 1. 1 times 1, 1. Cos x there, it is 1. 1 times sin x, it is sin x, okay? So we are going to multiply this part by cos x, and also the top part by cos x, okay? What we want to do is that we want to eliminate this cos down there. So this one and that would divide, so that we won't have any cos in the denominator, right? Okay, so this, when you simplify cos x times cos x, that is cos x squared over, here we have only remained with 1 plus sin x. So when we reach this part or this stage, we need to use another identity. So the identity that we are going to use here, we are going to use the Pythagoras identity. So the Pythagoras identity states that cos squared x plus sin squared x is equal to 1. So you need to be familiar with this identity. Cos squared x plus sin squared x is equal to 1. So now we are going to make cos squared x in this identity as a substitute formula. So it's going to be cos squared x is equal to 1. This one will come to the opposite side. That is negative sin squared x. So where there is cos squared x, we're going to replace it with that, with 1 minus sin squared x. Okay? So let us make another page, okay? So we said we have got cos squared x over 1 plus sin x. And then where there is cos squared x, we are going to replace it with 1 minus sin squared x. 1 minus sin squared x over 1 plus sin x. So 1 minus sin x squared we can use, or we can simplify it or expand it using the difference of two squares, right? So for example, if you've got, let's say 1 minus 4, right? Yeah, so if we've got 1 minus 4, we can write it as 1 minus 2, 1 plus 2, right? So we can write it as that to give us the same thing. So same applies to here. So there we're going to say 1 minus sin x multiplied by 1 plus sin x. It is the same as 1 minus sin squared x. Then divided by 1 plus sin x. And then we've got the common factor 1 plus sin x, 1 plus sin x. So the common factor will be cancelled. Then we're going to remain with 1 minus sin x. So this is the solution. We've proved this is what we had earlier on the right hand side. So if you can see very well, if you find that, or if you can check, you find that this is what we had earlier on in the question. So we proved that cos squared or cos x over sec x plus tan x is equal to 1 minus sin x. Let us now go to question 7b. Let us prove another identity. So question 7b, we've been given an identity which is open bracket 1 plus sine theta plus cos theta squared is equal to 2 open brackets 1 plus sine theta, okay, open bracket 1 plus, okay, because of space I just write cos here, 1 plus cos theta, cos bracket. So we need to show that what we have on the left hand side is equal to what we have on the right hand side. As I said here on, you should start with the most complicated part. So our most complicated part is the left hand side. So we are going to start with the left hand side and show that it is equal to the right hand side. So what we are going to do, we are going to expand 1 plus sine theta plus cos theta. So this one can be written as 1 plus sine theta plus cos theta times 1 plus sine theta, so sine theta plus cos theta, okay, because it is squared there. So we are going to expand this. 1 times everything, it's everything, right? 1 times everything there, it is everything there. So we're going to have 1 plus sine theta plus cos theta. And then let us expand or multiply sine theta times everything there. So sine theta times 1, that is sine theta. Sine theta times sine theta, that is sine squared theta. Sine theta times cos theta, that is sine theta cos theta. And then, so we expanded sine, right? Now let's go to cos theta. Okay, so now cos theta. So cos times 1, that is cos theta, right? And then cos theta times sine theta, that is sine theta cos theta. And then cos theta times cos theta, that is cos squared theta, okay? So this is equal to, so we can now add, right? We can add what we have. So we can add what we have. So we've got 1 sine theta, and then we've got sine theta here. Where else? So, and then even there, right? So we've got 2 sine theta, and then plus we've got cos theta there, and then even here cos theta. So we've got 2 cos theta, okay, and then plus what else do you have? Sine theta, cos theta. So we've got sine theta, cos theta. So let us locate it where it is. So we've got sine theta there, and then cos, and then another sine theta there. So when we had them, so sine theta, cos theta, sine theta, cos theta. So when you had them, it is you're going to have 2 sine theta cos theta. What else do we have? We've got sine squared theta, right? So it is just alone. So sine squared theta, and then plus cos squared theta. So plus cos squared theta. And then if you remember in the first question that we had, I mentioned you something that cos squared theta plus sine squared theta is equal to 1. It's an identity called Pythagoras identity. So this part plus that cos squared theta here plus sine squared theta is equal to 1. So that one plus the one that we have here are going to have 2, right? And then plus that. So we are going to have 2 plus this. So this part is going to be simplified to 1, and then plus that one there, 2. Okay? So, okay. So we say that here we've got 2 now, plus 2 sine theta plus 2 cos theta, and then plus 2 sine theta cos theta. Okay? So this is equal to. So now we can see that 2 is common, right? So 2 is common throughout. So 2 can be taken outside of the brackets, and then or we can factorize it. So when we factorize it, we take 2 outside, we're going to remain with 1 plus sine theta plus cos theta, and then plus sine theta cos theta. So what we've just done is that we've taken 2 outside. So cos theta. Okay? The next thing that we're going to do, we are going to group these things. We are going to group them. So let us say what we are going to do. Okay, so we're going to say sine theta is there, and there we've got sine theta, right? So we're going to put those with common variable together. Okay, so we've got sine theta there, and even there is sine theta, so we're going to combine them together. So we're going to say sine theta. Okay, so bracket sine theta, this one plus sine theta cos theta. Okay, and then like that. What else are we going to do? So we're going to add this one plus cos theta. So we're going to add that one plus cos theta. So we say 1. So we can put okay, plus there. So we say 1 plus cos theta. Okay, and then what we are going to do next is that when you see there and their sine is common, right? So sine can be taken outside of those brackets. So we can say sine can be taken outside, sine theta. Then there we are going to remain with 1 plus cosine, they are going to remain with cos theta. So cos theta, like that, right? And then there, what is common there? It's only 1, right? So 1 is common. 1 and 1 is there, it's common, okay? Nothing else apart from 1. So we'll say positive 1, or just say 1. Then you remain with 1 plus cos theta, okay? Like that, double brackets. So if you see that this part and that part is the same, right? So we can tell that we are correct with what we are doing. So this is going to be equal to 2. Okay. So what do we do here? So what we are going to do is that we're going to get that plus that. So that is 1 plus sine theta. Okay. And then we are just going to get 1 because this and that is the same thing. So just get 1 plus cos theta. So we are done. As you can see, this is the thing that we had earlier on the right hand side. So we've proved that open brackets 1 plus sine theta plus cos theta close bracket squared is equal to 2 open brackets 1 plus sine theta close bracket times open bracket 1 plus cos theta close bracket. So this now should be done as simple as that. Okay, I hope you got a concept. So now let's go to question 7c. Question 7c. So question 7c, we've been given the identity secant squared theta times cosecant squared theta is equal to secant squared theta plus cosecant squared theta. Okay, that is cosecant, sorry. Okay, cosecant squared theta. So secant squared theta multiplied by cosecant squared theta is equal to secant squared theta plus cosecant squared theta. Then we've been told to prove or to show that either side is equal to the other side. Okay, so if you want, you can start from this side or from that side, you see, but it's always good that if you try this side it's not working, try the other side. Try to use the other side to show that it is equal to this. It's not always mandatory to show that, or to use the left hand side. No, you can use the right hand side to show the left hand side, or you can use the left hand side to show the right hand side, whichever is working. So I'm gonna use the right hand side to show the left hand side. So secant squared theta plus cosecant squared theta should be equal to that. Okay, so here we are going to use the inverse identities, trigonometric inverse identities. So we are going to rewrite secant squared theta and cosecant squared theta. So secant squared theta is equal to 1 over cos squared theta. 1 over cos squared theta plus cosecant squared theta is equal to 1 over sine squared theta. 1 over sine squared theta. What this simply means that secant squared theta or secant theta is an inverse function of cosine. You see? Or cosine is an inverse function of secant. And then cosecant it's an inverse function of sine, or sine is an inverse function of cosecant. So what do you have to know? So what we are going to do now is to find the common denominator. So the common denominator, what we do is to multiply this by that. So that is cos squared theta times sine squared theta. Okay? And then cos squared theta into that, it is sine squared theta. Sine squared theta times this one, that is sine squared theta. Sine squared theta into that, it is cos squared theta. Cos squared theta times 1, that is positive cos squared theta. And then if you remember this part, the numerator now that we have is that it is equal to we can use the Pythagoras identity, right? Which says that cos squared theta plus sine squared theta is equal to 1. So sine squared theta plus cos squared theta is equal to 1, using that identity that I'm talking about. So you can say this is equal to 1. Okay, 1. Okay, I'm just using, okay, that is 1 over cos. Sorry, so that is cos squared theta times sine squared theta. Okay? So now, let us separate them. We're going to separate them. Okay? Okay. So, we had 1 over cos squared theta times sine squared theta. So, this can be written as 1 over cos squared theta times 1 over sine squared theta. What I've just done is that I've separated this. I've separated like that. You see? Because when you multiply cos squared theta times sine squared theta, it's going to give you the same denominator. Okay? So, we know that 1 over cos squared theta is equal to what? That is equal to secant squared theta, because 1 over cos squared, 1 over cos sine, 1 over cos theta, it is an inverse function of secant, right? And then 1 over sine theta, it is an inverse function of cosecant. So 1 over cos squared theta is equal to secant squared theta. So that is secant squared theta. And then remember there is multiplication there. So multiplied by 1 over sine squared theta is equal to cosecant squared theta. So cosecant squared theta. So this can be written as squared theta, eliminating that dot there, cosecant squared theta. So this is the final solution. So this is what we had on the left hand side, right? So we've shown that what we had on the right hand side is equal to what we had on the left hand side. So this is all on this question. Okay, so I'm just going to end here for this video. I'm going to post another video soon where I'm going to finish the remaining questions under question 7 and 8. So please make sure that you subscribe and hit the notification button so that you won't miss any video that I post in the future. Thank you.